turn it on. All right, guys, I hope you had a great Christmas break. It was a nice, longer break than normal, but we're going to get at it here. I think everybody has the AMI snow day packet, yes? The 7-day packet, because each one of those, again, is 1 day. Yep, 1 day worth of problems on each one. I have a feeling there's a good chance, I think y'all know Friday might be out, so each day we're out, just do it 1 through. If we're out just 1 day, just first page. Out 2 days, first, second. We just keep going through that packet. I put 7 days worth just so we have more than enough just in case. If not, we make it all the way through the end of the year and we don't use any of them or don't use all of them. I will take the rest of them for extra credit. So if you want to go on and do all of them, that's fine. If not, that's also fine. So they're not too bad. They are, well, factoring. That AMI snow day packet is factoring. And what we're starting off this semester with is factoring. Part of the reason we're starting off with factoring is because the next chapter, our chapter on rational equations, our fractional equations, is going to require factoring. It's going to help us be able to simplify rational expressions and solve rational equations. We're going to need to factor. Now, specifically, we consider an equation a rational equation if we have variables in the bottom of a fraction. This is really going to be the first time we've dealt with fractions where variables are in the bottom. We're used to them being on top, out to the side, but not necessarily on bottom. So that's what we're going to be doing. And I also thought it'd be nice, instead of jumping straight from the break into the chapter on rational equations, we'd go back over factoring, something we've done before, get our feet wet, and then dive right in. Now, this first problem that we're going to do here is probably going to be the longest one that we do this entire class period. Not because the problem itself is going to take a while, but again, going back over the steps. Because our first step, whenever we factor, is to find the greatest common factor. There's not always going to be a greatest common factor, but if there is, we need to factor it out. So our first step is to see if there's a greatest common factor between the terms. B squared 12b 20, there is no greatest common factor between these 3 terms. So we move on to step number 2, which is our 2 sets of parentheses with 3 spaces. We're going to write our 2 sets of parentheses with 3 spaces. And so that takes us to step number 3. Step number 3, find the signs. If the third term is positive, then the signs are the same and match the sign of the middle term. If the third term is negative, then the signs are opposite. So if the third term is positive, then the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. This is part of why the first problem is going to be the longest one. So if we look at this one here, the third term is what? Positive or negative? Positive. So the signs are the same and match the sign of the middle term. So since the third term is positive, the signs are the same and match the sign of the middle term, which is also positive. So both the signs are positive. The third step is a lot of writing for not a lot. Let's go on and get the last two steps. Step 4. Find the factors of the first and third term. First and third terms. And the last step is to plug in these factors and check. Plug in and check. We want to plug the factors in and check and make sure that they are the correct factors. So if we look at this one here, our next step is to find the factors of the first and third terms. So our factors of b squared, what multiplies together to give us b squared? B and b. Those are the only factors that multiply together to give us b squared. And since there's only one set, we're just going to go on and plug them in. Now the other set of factors that we're looking at are the factors of the third term, the factors of 20. 1 and 20, 4 and 5. I have a feeling we're wanting to try 2 and 10, yes? Or does it matter which one goes first? No. And part of the reason it doesn't matter is, well, we're going to check it. Now, most would say we need to multiply the whole thing out. Most textbooks would also agree with that. Now, it's not that I don't disagree with it. I think a little bit of it's repetitive and not necessary. Because one of the things that I would say to check first is b times b. Well, b times b is what? B squared, yes? Well, where did we get the b and b from? B squared, they're the factors of b squared. They should multiply back together to give us b squared. So I don't see a whole lot of reason to check that, because that's where we got it from. The other one is the 2 times 10. Because 2 times 10 is 20. Well, where did we get 2 and 10 from? 20, it's the factors of 20. The only way those won't multiply together to give us the first and third term is if we got the wrong factors. If we put 4 and 6. That's 24, not 20. So unless we get or list the wrong factors, it's going to give us the first and third term. There's not a whole lot of reason to check that. Because the main one we want to check for, and the one that changes based off the factors of the first and third terms, the middle term. That's the one we want to check. And that's this here, our b times 10, which is 10b. Our 2 times b is positive 2b. And 10b plus 2b is 12b. Is that the middle term we wanted? Yeah. And since that is the middle term we wanted, b plus 2 times b plus 10 are the correct factors. Questions on this here? And that will be the most time we spend on any of these problems today, because we're not having to wait for me to write the steps or for y'all to write the steps. We just had to do it once just so we did get them down again. Now, if we look at this next one, a squared plus 4a minus 32. Is there a greatest common factor? No. Now, one of the ways that I have gotten used to, and especially looking at these and seeing if there is a greatest common factor, is really looking at mainly the first and third term. Are a squared, is there a number in front of a squared? No, so most likely there's not a number that's going to go into all three. Because if there is, it's going to have a number. Not guaranteed to have a greatest common factor if there's a number in front of a squared, but more likely is going to happen. The other place to look is the third term, because we can have variables as greatest common factors. So if it has a variable, there's a chance we can factor that variable out. Since we don't have one in either place, there's not a likelihood there is one. Here, there's not a greatest common factor. So we'll move on to our two sets of parentheses with three spaces. Find the sign. If the third term's positive, the signs are the same and match the sign of the middle term. Third term is negative, the signs are opposite. So since the third term is indeed negative, one of the signs is positive, one of them is going to be negative. Now really at this point it doesn't matter which one's positive, which one's negative. I default to putting plus in the first set of parentheses, minus in the second. Doesn't really matter, we just got to put one plus and one minus. Factors of a squared, a and a. Only set of factors for a squared. Factors of 32. 1 and 32. 2 and 16. 4 and 8. Questions on any of this so far? Most of this coming back slowly. 8 and 4. 8 and 4. We can check it. A times negative 4 is negative 4a. 8 times a is plus 8a. And negative 4a plus 8a, 8 minus 4, positive 4a. Is that the middle term we wanted? Now, if we do get the correct number but wrong sign, all we need to do is flip the signs, change the signs. And it is possible to get the correct number by switching the numbers, by switching the 8 and 4 to try to get there. And it works well as long as the first set of terms are just a and a, x and x. Because if it worked out, let's just say it was 3a and a, you have to switch the 3a and a and the 8 and 4. We have to change everything, which is a little less convenient than just switching the two signs. But to each their own, because both ways work. Questions on this here? Are you ready for the next one? X squared minus 17x plus 72. Is there a greatest common factor between these three terms? No, since we just have x squared, no variable shared. Yeah. Two sets of parentheses with three spaces. The third term in this case is what? Positive, so the signs are the same and match the sign of the middle term, which is negative, so they're both negative. Now we need to find the factors of the first and third term. Factors of x squared. X and x. So that's not bad. Now factors of 72. 1 and 72. 2 and 36. Because we know 2 works because it's even, yes? Is 3 a factor of 72? Yeah, because one way we can tell is if the number itself, if we add the digits and that's divisible by 3, the number itself is. 7 2 is 9. 9 is divisible by 3. So we have 3 and 24. 4 and 18. No 5 because it's not a 0 or 5. 6 times 12. 9. And that's it. Because that's all the factors. One of the nice ways to know if you have all the factors is when you're listing those factors out, especially increasing on the left-hand side. If the right-hand side of that column meets the left, we're done. Because the only number after 8, well, the next one would be what? 9. It's already listed. We don't have any others. But now the question is, which one of these sets of factors do we want to try first? Or any of these on the list that we think would probably not work? 1 and 72 is probably not going to work. 2 and 36, 3 and 24. So we're really looking at the bottom 3 or bottom 2, yes? Let's try 8 and 9. Yeah, because I'd eliminate 1 and 72, 2 and 36, because they're a little too big. Now, if we look at this here, x times negative 9 is negative 9x. Negative 8 times x is negative 8x. So we have negative 9x minus 8x, negative 9 minus 8 is negative 17x. Is that the middle term we wanted? Now, the 30xs, the graphing calculators won't calculate negative 9x minus 8x because it needs a value for x. But it will do negative 9 minus 8 just fine. And since they are like terms, it'll still have x. Questions on this here? Are you ready for the next one? X squared minus 7x minus 30. Is there a greatest common factor between these 3 terms? No. We'll move on to our second step, our 2 sets of parentheses with 3 spaces. The third term is what? Negative. So that means our signs are opposite. One's going to be positive, one is going to be negative. That takes us through steps 3. Step number 4. Factors of the first and third term. Factors of x squared are x and x. Only one set of factors for x squared. Our factors of 30, we have 1 and 30, 2 and 15, 3 and 10, 5 and 6. Which one of these do we want to try first? 3 and 10. Which one goes first? 3. 10 goes second. X times negative 10. Negative 10x. 3 times x is plus 3x. Negative 10x plus 3x is negative 7x. That is indeed the middle term we wanted. Questions on these here? We feel good about these here? We're going to go on and skip this one. That's why I went on and gave you the factors. because I feel like y'all are getting the hang of this. It's a nice thing about going over it again, seeing it again. Familiar territory. We're ready to look at the next type. It's a little bit different, not a lot, just a little bit. Because what makes this one different than all the ones we've done so far? There's something in front of r squared. So is there a greatest common factor between these three terms? Yes, there is a greatest common factor of 2. And since there is a greatest common factor, it means we can factor that out. And we factor something out, really what we're doing is taking every term and dividing it by the greatest common factor. So our 2r squared divided by 2 is r squared, plus our 6r divided by 2 is 3r, and 8 divided by 2 is 4. But then the rest of the steps are the exact same. We still have 2 sets of parentheses with 3 spaces. The third term in our case is what? Negative, so the signs are opposite. One's positive, one's negative. Which moves us into the next step, our factors of the first and third term. Factors of r squared are r and r. Yes. Hopefully we got enough of it over the last few weeks. Yes. Rest and relaxation, r and r. Now, factors of 4. 1 and 4, 2 and 2. Which one do we want to try first? 1 and 4. 4 and 1. Now the middle term we're checking for is positive 3r, not 6r, since we factored that 2 out. R times negative 1 is negative r. 4 times r is plus 4r. And negative r plus 4r, 4r minus r, is positive 3r. Is that the middle term we wanted? So our final factorization is 2 times r plus 4 times r minus 1. So we do need the 2 as a part of the factors, because it is something we factored out. We did factor it. Questions on this here? So is this any really is this any different than what we did at the start? No? That'll be nice. Do we want to do 9 or 12? Problem 9 or problem 12? 12. Let's look at 12. 5r squared minus 30r minus 135. Is there a greatest common factor between these three terms? 5. So we're going to factor 5 out. We're dividing each term by 5. So if we divide 5 by 5r squared, we're left with r squared. If we factor 5 out of 30r, we're left with 6r. If we factor 5 out of 135, we're left with 27. Now, there are no other common factors because we did pull out the greatest common factor of 5. So we can move on to step 2, our 2 sets of parentheses with 3 spaces. Since the third term is negative, the signs are opposite. One's positive, one's negative. Factors of r squared, r and r, r and r. And we also need the factors of 27, which is 1 and 27, 3 and 9, yes. 1 and 27 or 3 and 9? 3 and 9, in that order. And we can check this here. 3 times negative 9, or r times negative 9, is negative 9r. 3 times r is positive 3r. And negative 9r plus 3r is indeed negative 6r. Is that the middle term we wanted? Questions on this here? We ready to look at the last two? Well, last 3 possibly. This one here, is this any different than what we actually did? It's actually not. Because what's the main difference with this here? It's not written in standard form. Really, all we got to do is rewrite in standard form, and then it's the exact same problem. Because there is no greatest common factor. We'd have 2 sets of parentheses with 3 spaces. Since the third term is negative, the signs would be opposite. Factors of x squared would be x and x. And the factors of 10 that we want are 5 and 2. So really, it's the exact same problem. It's just not written in standard form. So I had to write it in standard form and then factor from there. Negative 2x plus 5x equals 3x. Not too bad. 9x squared plus 30x plus 6 is their greatest common factor. Three will go into all 3 terms. Because 90 is divisible by 3, 30, and 6 are all divisible by 3. So if we factor this out, we're left with 3x squared plus 10x plus 2. So we're able to factor the 3 out first, the greatest common factor. 2 sets of parentheses with 3 spaces. Since the third term is positive, the signs are the same and match the sign of the middle term. So we have plus and plus. Factors of the first term. So we have 3x squared. Factors of 3x squared. Well, the x squared part we know will be x and x. Factors of 3 are, well, 1 and. So we can just plug the 3 in one of the 2 spots. Factors of 2, our third term. We just have 1 and 2, yes? All right, let's check it for the middle term. 3x times 2 is 6x. 1 times x is x. 6x plus x is 7x. Is that the middle term? No. Well, we can switch the 1 and 2. Three x times 1. 3x. 2 times x. 3x plus 2x is? So this part here, we can't factor it any further. It is factorable, but all we can do is take out a greatest common factor, yes? Now, it would be nice to be able to check and see if a quadratic is factorable, because that would be nice to know so I'm not trying to check everything. Because here, when we're looking at this, we're trying to see what factors of this first and third term is somehow going to get me to 10. 3 and 2 does not look like it'll get there. Now, one way we can check it, we're not going to use this entire equation. Because I think y'all remember this equation here, yes? The quadratic equation. Now, the quadratic equation is useful in solving quadratic equations. Quadratic formula is useful in solving quadratic equations. Now, all right, guys, focus in. Now, the reason I bring this up, and we have this here, is if it's factorable, it means the solution are either fractional, rational, or integers, nice whole numbers, yes? Well, this here would give us the answers. Now, if this part here, this square root, gives us square roots, that means it's not going to factor. If it gives us I terms, it's not going to factor. So what that tells us is I can take the square root of b squared minus 4ac from any of these quadratics, and if I get a nice number, if I get a number without a radical or I, it means it factors. If I don't, it means it doesn't. So if we look at this problem here, square root. So our b term, in this case, is 10. We can say the square root of 10 squared minus 4 times our a, which is 3, times our c, which is 2. So if I plug this in and get a radical, it means it's not going to factor. If we look at the square root of 10 squared minus 4 times 3 times 2, we get 2 squared of 19. That tells me it's not going to factor. So this is as far as it goes. It is factorable. We did factor a 3 out, but that's it. It can't go any further. So if you're not sure, or it seems like it might not factor, I'd plug in the square root of b squared minus 4ac, see if we get a nice number, because if we don't, that's as far as it goes. Because here, if we wanted to check this one, it'd be the square root of, so our b squared, 3 squared minus 4 times a times c. Square root of 3 squared minus 4 times a times c is 7. Now, the 7 doesn't mean a whole lot to us because we're not solving, but it is telling us that this will factor, that we can actually factor it. Because if we get a number that doesn't have a square root, doesn't have I, for the 30xs, if it does have I, it's imaginary, it'll just throw in domain error. It won't take the square root of a negative. But the reason that's nice is, well, we can say this doesn't factor. Like with this next one here, 5x squared plus 9x plus 2. If we wanted to check it, second square root yeah, okay, I got it right. Because our b is 9, so 9 squared minus 4 times a times 2 is square root of 41. So that tells us we can't factor it with our two sets of parentheses. Is there a greatest common factor between these three? And this one here is not. I don't know why I just second guessed myself on how to spell factorable. It is not factorable. There's nothing we can do with it. and that's it. At, so yes, it will be due at the end of the factoring test. So there will be a test over just factoring, doing this here, because I thought it'd be a nice way. So this is just the homework. So we'll test. So we'll test over factoring, because unlike the first semester, we don't have the syllabus grade. We went to see my family and